All right, let's talk for a moment about negative exponents. Now, negative exponents seem kind of confusing, but in reality, they're not. When you think of a negative exponent, you need to think of the reciprocal, because that's essentially what it is. So, for example, if we have 2 to the negative first power, and you were to type that in your calculator, which we won't be using, by the way, will give you 0.5. Well, 0.5 is the same thing as saying 1/2. So the reciprocal of 2 is 1/2. That's what 2 to the negative first power means. If I have 2 to the negative second power, again, we want the reciprocal. That's what the negative stands for. So I can change this problem to 1/2, and we still need to raise it to the second power. So my answer is then 1/4. Again, 2 to the negative third power. The negative means, we want the reciprocal. Then we need to raise it to the third power. So 1/8. If we already have a fraction, let's change it to 1/3, and we're then raising that to the negative first power. Again, we just want the reciprocal. Well, what's the reciprocal of 1/3? 3. If it's 1/3 to the negative second power, the negative exponent means I want the reciprocal, and then I need to square it, so 9. Okay? When you have a bunch of values all being raised to negative values, after you're done simplifying, what you do in this case, you don't want to leave the answer with negative exponents. That's considered unsimplified. But anything that has a negative exponent needs to be put in the opposite location. So a would go to the denominator, and c would move to the numerator. So my final answer would be b cubed c to the fourth all over a to the first power. You don't have to put the first power if you don't want to. It's not wrong if you do, but it's just unnecessary. So let's look at a couple of examples here. All other rules apply, though. Negative exponents, the multiplication rule applies, the division rule, power to a power rule, all those applies. Please be careful, though. Only the x in this case is being raised to the negative fourth power. So we're going to just multiply 7 times 4 to get 28. And then we're going to apply our rule for multiplication, adding the exponent to get x to the negative third power. Now, starting today or tomorrow, we don't want to leave that as our final answer. This negative exponent is considered unsimplified. So to fix it, we simply move it from the numerator, move its base from the numerator to the denominator, and raise it to the third power. That's how we take care of negative exponents. In this case, we're raising a negative second power to a negative fourth power. So we're going to, when we raise a power to a power, we multiply. We have a 2 that has nothing happening to it. So there's my 2. And then I have an a to the negative second power. Everything's being multiplied. So I simply add the exponents. And my final answer is good. There's no negative exponents in it. For this last one, there's no negative exponents in here, so I'm going to put a negative 3 power there. So everything in this parenthesis is being raised to the negative third power. So 2 gets raised to the negative third power. X squared gets raised to the negative third power, giving me x to the negative 6th. And then I have a 3, and then an x cubed. Let's further simplify. 2 to the negative third power means that 2 actually needs to be moved into the denominator. The 3 is good where it is, so it's going to stay in the numerator. And then we can go ahead and combine our x's, and gives us x to the negative third power. Further simplifying, we need to move the x to the negative third to the denominator, and 2 to the third power is 8.